Okay. So I guess you are all new at Dome, and it's very important to start with a short introduction to show you. Just 1 second to open my 01. Okay. So can you see? Just confirm if you can see my screen.
Yes, we can.
Okay, great. So it is clear on the screen that the curriculum of 01 is divided into five main sections. The first topic is the computer knowledge and data science. The second topic is office application. The third topic is 3D design and animation. The topic four, algorithm coding, robotics, and microcontroller. And topic five is artificial intelligence and machine learning. And uh, uh, it is clear that you can see that the main section, which is the algorithm coding, robotics, microcontrollers, and database, is the biggest since you have many topics inside. And one of the major topics that is challenging for teacher is Arduino. And here, by Arduino, we can say that it's really important to understand the approach. What is Arduino, and why students should learn about Arduino, and specifically that if you go on internet and you search for educational resources on YouTube or other resources, it will not be simple enough for the teachers and for the students to understand or to start teaching Arduino, especially from grade 7 up till grade 12. This is why in my presentation today, I'm going to open my chat and I will share with you two documents which are Arduino level 1 and Arduino level 2, two PowerPoints. I'm uploading them right now. So just it will take like a few seconds. And please, if you can confirm me on the chat the moment you receive them. Please, did you receive them?
Yes, we received the file, sir.
Okay. So I will share the first. Do you have any question regarding the table that you see on the screen in terms of the scope and sequence for the different grades? Do you have any concern or any recommendation or any question? What's wrong? Are you still with me? Can you hear me? Sorry, can you hear me?
Yes, sir. Yes, yes.
Sorry,
You're
sorry.
audible.
I have all right, okay, great. Sorry, excuse me. Uh, so uh, so I will go through the PowerPoint I sent you while explaining. You see now the PowerPoint, right?
Yes, we do.
Okay, great. So this PowerPoint, you can take whatever you want from it in order to share it with your students. It's very important in the classroom to make this approach in order to make students understand the concept of the microcontroller in general and specifically Arduino. So basically, when we are going to teach Arduino, keep in mind, you as teachers, that you have to explore 5 layers for teaching Arduino. And slowly, you will understand more what I mean by 5 layers. Because if you do not create this segmentation in teaching Arduino, since it's in direct contact with hardware, things will be a little bit confused between one layer and another. And when we talk about 5 layers, I mean how you are going to explain the chapter Arduino for your students. And to explore the different layers to teach Arduino at school, you have to go through those different layers. And what is applicable for Arduino, it's applicable for any other topic in direct relation with the hardware. What I mean in direct relation with a hardware is that usually when we teach Scratch or coding or Office or Paint or any software for students, students does not have any contact with a hardware. They do not manipulate the hardware by itself because it's only on the screen. But when we go through the what we call the hardware, like robotics, Arduino, microbit, 3D printing, so we have to take into consideration the layers to connect it with the curriculum. And from here, we can introduce the definition of STEAM and to move forward. So if you are asked to give the definition of STEAM, it's really clear that when we talk about STEAM, we talk about offering students skills in many subjects in order to let them create or to reinvent a product or a solution for a problem. And here, this is the most important definition that you are asked to keep in mind, because now when we teach ICT, it's not for the aim of teaching a computer or ICT and that's it. No, it's for the benefit of reaching a stage where students will invent, will reproduce hardware, STEAM projects by creating new ideas or by reinventing a solution or for a problem or a product. So keep in mind this definition, because this will help a lot to simplify the task for you. And before starting this webinar, a major question should be asked: the why. I mean, why Arduino should be given in the ICT curriculum. It's very important for you to make it clear for students, to convince them that it's really a must for students to be convinced about why we have to learn Arduino. So once you got the answer to the why, you can proceed in a secure and confident way to explain for students the Arduino chapter. And from there, the major obstacle for ICT teachers to teach Arduino is to get a solid background in electronics and programming in order to create projects. Because I'll take myself as an example. When I started with Arduino, to be honest, I was afraid because I do not have a solid background in physics, in electricity, in electronics, in order to teach Arduino in a clear way. But it's a challenge that you have to take. And once you as teacher, you will have this solid background regarding the hardware, believe me, it will be very simple for you to have this teaching process. That's why hardware and coding concept will be developed during this webinar. And level one, which is we are going to explore it today, skills will be covered during this session. Level two skills will be done on a later stage. So we'll start the webinar by introducing the word of microcontrollers in order to be able to find or to conclude the answer to the why. Okay. And from there, once we get the answer to the why, we should define the skills to be offered to our students reaching grade 12. This is why it's very important to know that when our students will reach grade 12, the major question is, should they have to get this background in electronics or in microcontrollers? Of course, yes, because what we are going to explore in the coming slides will be really clear. So the why, I'm answering the why right now. So the main skills that should be developed in ICT and robotics in order to make students understand tomorrow's world are coding, machine learning, artificial intelligence, and IoT. And we offer those skills in an educational curriculum tested for more than 25 years. And I will start, and I think that when you are going to explore this PowerPoint with your students, you have to start with slide number 13. So microcontrollers as a definition, it's the word microcontroller is divided into two words, the micro, which is small, and controller, which is it controls something. And here I can see that a microcontroller is used in all electronic devices that we use every day: the elevator, the fridge, the washing machine, the TV, the remote control, the car, etc. and etc. So please keep in mind that the moment any of the academic directors or parents or students will go and ask you why you are teaching Arduino in the ICT curriculum, the answer is simple. Simply because the microcontroller is found in any electronic device that we are using every day. And you can give the example of the elevator, the fridge, the washing machine, the TV, the remote control, etc., etc. So, in order for our students to understand better, what how those electronic devices are working. So it's really clear that we have to give them this chance to explore deeply in an educational way those concepts. And the microcontrollers, why they are used. So a microcontroller is used in an electronic device to control to control it for a better functioning. And the simple example that we can give is when the door of the fridge is open, the light will turn on. And who programmed the microcontroller? So simply a microcontroller used in an electronic device is programmed only by the manufacturer. So all those questions will be implemented in layer one while teaching the Arduino topic. And as I said before, in Arduino, while teaching, we have 5 layers. So I'll be back later on. But the first layer is a general introduction about how to what is Arduino. So all those questions will be a solid background for the students to understand what is a microcontroller and how to program it and so on, where we found it and who programmed it and so on. Another main definition should be given is IoT, which is the definition. And by IoT, I can understand that as known as Internet of Things is the future technology that will link every single device to the internet. And IoT will allow us to control by using an app those devices remotely. Okay, so all what I'm talking about right now are linked together. I mean, Internet of Things, microcontrollers, machine learning, later on AI. So all those are related to one topic, is that we are going to live in a world where all the electronic devices will be providing data, and we as a human being, we have to explore and to manage all the data received by the microcontrollers and the sensors in order to make analysis, to have a deeper look for the data analysis that we are receiving. And if we go for the IoT, we can see that the IoT is embedded in shops, in airports, in stations, in mobile devices, in data center, in home and buildings, in cities, in ships, airplane and trains, in factories. So everywhere, IoT will be the core of the manipulation that we are manipulating in order to explore more and more the data collection of information. And IoT will be the solution because it will lead us to a world where less pollution, less consumption of natural gas, resources as gas, electricity, better medical life, better production in factory and agriculture, less traffic, etc., and etc. And here I can give an example, a practical example. 2 or 3 years back, I read a document made in Barcelona. The mayor of the city embedded IoT in the city regarding the irrigation, the traffic, the street lights, the waste management collection. So in every public service, IoT was integrated, and I can tell you that millions of dollars were kept, not spent, because we have an economy of scale regarding the water consumption, traffic, waste management, and every sector where the IoT is embedded. So it's impossible to reach the IoT world. It's impossible to reach the IoT world without understanding the components of the microcontroller and how it functions. That's why the introduction for students to the world of microcontrollers is a must. And from here, I can say that IoT as a solution is not possible to reach without the integration uh, of microcontrollers in the devices to be connected. I'll move forward. Sorry. I'll move forward. So IoT as a solution is not possible to reach without the integration of microcontroller. And the conclusion, after this brief introduction, it's now possible to answer why it's a must for students to learn how to program and work with a microcontroller. And to move to move forward in this presentation, what we need to create an educational circuit to understand how to reach IoT, you need electronic devices such as sensors, motors, a pump, screen, LED, push button, etc. You need a software and a solid background in electronics. So teachers should keep in mind first that the input and output devices that are connected directly to the computer are limited to keyboard, mouse, scanner, microphone, screen, printer, speakers, projector, etc. That it's impossible to connect directly a sensor, a LED, a motor, a push button, or a pump to a computer. So this is why it's very important to know that the microcontroller we need an electronic board, the microcontroller that will play the role of linking the computer to all the electronic devices that could not be linked directly. So from here, we have to know that the role of the microcontroller will be a major role by linking the computer where we will create the program to the device that is embedded with sensors, with motors, etc., etc. So this is very important. So microcontrollers as brands, you have to know that for educational purposes, many brands are available on the market. Only two major brands leads. We have the first one, which is the Arduino, the Italian brand, which is dedicated for upper grades starting from grade 7, and the microbit, which is the British board created by the BBC, which is dedicated for lower grades starting from grade 3. And what is the difference between Arduino and the microbit? And this is what you should know while teaching those topics, that Arduino does not contain any input-output devices, so it will be hard for lower grades who don't have any electronic background to build a circuit using Arduino. And the microbit is loaded with a display LED screen of 25 LEDs, 2 push buttons, 3 sensors, and other features. And this will facilitate the learning process for kids in lower grades. So some examples before moving to practice. Here we have the parking gate with Arduino, so we can embed the Arduino board with a ultrasonic sensor with a servo motor and so on. Some example before moving to practice. So the plant irrigation with Arduino, we can have object detection, we can have humidity and temperature detection. So all those examples will give motivation for students in order to learn more and more about this topic. So here some examples before moving. So, sorry, excuse me. So in order to manipulate Arduino, students must be introduced to the hardware and to the software. So if you remember at the beginning, I've said that Arduino teaching should pass through 5 major layers. Please keep this in mind. The first layer is the introduction to Arduino, the word of Arduino, and all the slides I've mentioned or I went through since the beginning till now. The second layer will be the hardware, and the students should know the use of each hardware and the characteristic of each hardware that we are using in Arduino. Layer 3 will be the software, how to create and how to program a software, the Arduino. And layer 4, it will be the link with Steam by embedding 3D design on a 3D printer and the Arduino. And layer 5 will be the competition, which will be like, as I said before, the competition Make X, maybe, or for the robotics, but for Arduino, you will find in the Saudi Arabian market many competitions, and some of the competitions will be using Arduino. So for the hardware, so now I'm talking about layer 2. So it's done with the layer 1, which is the introduction. Now I'll be moving to layer 2. Do you have any question before I start with layer 2, please? Any question, or it's okay, please?
No, sir, we are good.
It's okay, fine, it's clear.
Yes, it's clear so far.
Okay, thank you very much. So the layer two, which is the hardware. So here you have to make students understand that we have the breadboard, which is the board which is essential for any project. It is used to link the input and output devices to the computer to perform a specific task. The breadboard, which will play the role of a socket wire just for the what we call to extend the possibility of making large projects. We have the LED that is considered as an output device, and it is a must to manipulate, to start learning Arduino, and this is what we'll be exploring in a while. Resistors are essential to protect the electronic devices, especially the LEDs. The motors, which is considered as an output device to perform mechanical actions. We have the servo motor and we have the DC motor. We have the buzzer, which is considered as an output device to reproduce sounds and musical notes. The ultrasonic sensor, which is considered as an input device to detect objects and measure distance. The temperature and the humidity sensor, which is considered as an input device to detect objects and it's wrong here. Which an input device to detect humidity and temperature, excuse me. Maybe you have to correct it in your slide. And of course, you have more than 37 sensors for this manipulation. And for the software, you have the official software, which is the Arduino software, where you will be writing your code in C++, okay, and to upload it on the board. And the other platform, which is a very good opportunity to explore the simulation is the Tinkercad, where students will build the circuit, will program it as scratch, and then once done, they can move it to the Arduino board. So I think that I will go directly to Tinkercad. Just allow me to open Tinkercad. So Tinkercad, here it is. So the moment you launch Tinkercad, it's a free software. Okay, as you will see, I'm already logged in. I will log out. So you will be asked to sign up. Here, please do create a personal account. It's free. So since I have my account already created, so I'll be connecting to my personal account. And the moment the platform is on, I have to select one of the three manipulation, which are even 3D design, circuits, or code block. And here, since we are talking about circuits, Arduino, so I will open the circuits. You will see on your right all the components and devices that you might need to build your circuit, and especially the Arduino board, as you can see here. And each time I want to program a device from the one I have here, so I can move it and start working on. So I will start basically with a simple manipulation. The moment I move the Arduino board, if I click on the code, I will see that there is a part of a code automatically built in. This is generated by the system. And in the forever loop, you can see that there is a set built-in LED high, wait 1 second, set built-in low, wait 1 second. So if I click on start simulation, sorry, excuse me. Start simulation. Okay, so you can see that there is a LED here, which is on the board. It start to blink with a delay of 1 second. I will go here and change the 1 second to 0.5 by 0.5. I will click on start simulation another time. You will see that the LED is blinking too fast. So I can say that the built-in LED, it's here to control if my board is working well. So look what I'm going to do. I will stop the simulation. I will hide the code. I will take a LED. And as you can see, the LED has two legs. You have the cathode, which should be connected to ground as a negative pole, and the anode, which is the longer LED that will be connected to digital pin 13. And if I click on the start simulation, you will see again that the LED is blinking and the LED on the board is blinking. What I'm going to do is to stop the simulation, to take the LED from 13 and to put it on 12. I click on start simulation, and I can see that this LED is blinking, but this one is not blinking this time. What I can conclude, and please but since I'm registering this session, so you can go back to this part because this is how you will be explaining what is the use of the digital pins here. So I can conclude simply that this LED, it has the address 13, same here and here. And the moment I move my my anode connection from 13 till 12, the LED will not blink. So I'm obliged here to open the code to select from the blocks set pin 12 to high. From the control, wait 1 second and duplicate set pin 12 to low and wait 1 second. And once it's done, if I click on start simulation, so you can see that, I don't know what's maybe the internet connection. So you can see that the LED 12 is blinking and the LED 13 is blinking. And to end this part, okay, if I move the anode and I place it to 7, all I have to do in the code is to change the address from 12 to 7. And if I click on the start, look how the LED is blinking. Okay, so this is what you have to start with your students in order to make them understand this feature of doing the first manipulation. So from here, we can conclude that all those digital pins are or should be connected to the anode, and each one has a unique address that I can control it using the the program using the LED. Down, I can see I have analog pins. We will be exploring them later on, not now. And here you have 2 ground pin, one 5-volt and one 3.3-volt, and that's it. This is all what your students should know, that you have 13 digital pins. You have a ground here, you have 2 grounds, you have 5-volt, and you have analog pins from A1 to A0 that we will be exploring later on. I will move to another step, which is I will add a breadboard to explain what is the use of the breadboard. And if I place my mouse on one of the dots or the holes, I can see that all the line is selected. And here also all the line is selected. And from the inside section, I can see that I have the columns are selected. And down, I have the rows selected. So what I can conclude is that if I delete the two cables or the 2 wires, and I place, just please give me 1 second. Okay, so if I place the LED on the breadboard, so I have to reschedule or to remake or to reinvent the structure of the cabling. So look what I'll be doing. I click here on the ground. I will take 1 cable and I will connect it to the first row. And now keep in mind that all this row is connected to ground. So it's very simple for me to add 1 LED, a second LED, a third LED, and even 4 LEDs. and all the anode, the cathode, will be connected directly from here. So I'll be adding the cathode here. Okay. Sorry, excuse me. Okay. So still I have to connect those LEDs to the digital pins. So I will take randomly 7 to the first LED, 5 to the second LED, 3 for the third LED, and 1 for the fourth LED. And now my circuit is done. So what we can conclude is that the breadboard help us a lot in extending our circuit. So I go back to my code. If you want to make them blink at the same time, look what I'll be doing. I'll take this. Okay. I will delete this, duplicate. So I will take 7, 5, 3, and 1, and I will duplicate all this, and I will put low, 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 and low. And believe me, students will have fun by working with this. See how it's simple. So if I want to make them, let's say, high and high, so I'm changing the scenario. So I have 2 on, 2 off, 2 on, 2 off. What I'm doing here is like 80% from the task in order to move to the real hardware. Because you know that here what we are doing is a simulation, but after the simulation, I'm asked to open my code, to click on blocks, to take blocks and text, and look how the blocks are generated into C++. So I copy my file, I go and open the Arduino software. Just give me a second. Sorry. Okay. Okay. I will select all the code shown on my screen, and I will paste my code. If I have the board connected to my computer, I can go to to Tools, Port. I will connect the port, and then I will upload with this button. And normally, if my circuit is correct, it should work. Properly. Okay. So if I want to make a summary about what we did right now, I believe that we explored the layer 1, which is the introduction to Arduino. We explored the hardware layer to get introduced to the major components that we are going to use, like the Arduino board, the breadboard, the LED resistors, motors, ultrasonic, humidity, and others. I showed you how to create my first circuit in, Arduino by using Tinkercad. And if you explore well inside the book of grade 7, 8, 9, it's a clear approach on how to step by step start developing all those programs. Okay, so and then we introduced the breadboard and how to link many LEDs and how to change the circuit in order to create a differentiation between the blinking. If this introduction is clear, believe me that the rest will be like a second step that you are invited to explore easily without any problem. So let us wait. If you have any question, please open your mic and do ask me in case you do not have any previous prerequisite in Arduino, and I invite you to open the two PowerPoint I sent, in addition to the recording I'll be sending right now, and to start manipulating and exploring. And in case you have any question, I believe you can contact me anytime by WhatsApp or by email. I'm typing my 9613380633, which is my phone number. So WhatsApp, so you can contact me anytime. Please do open your mic and feel free to ask me any question you have.